Frank and Drew's Reviews. We have a selection of beer for you. I hope you'll enjoy your time with us.
What's up, YouTube? On this episode of Frank and Drew Review, we're doing something completely different.
Yes, we're going to be making a catch can. Well, only modeling a catch can.
Crucial. Drew knows a lot more about using Autodesk Inventor than I do. I'm just competent enough to be dangerous. I'm pretty garbage at it. But I know what I'm making, and I have parts.
So, a little bit later on, we'll be kind of walking through a little narration and modeling. Mm-hmm. Don't know how exciting it's going to be, but maybe you'll learn something. And maybe we'll figure out what we're actually doing.
Hopefully.
All right, stay tuned. All right, welcome to another episode of Frank and Drew Review. Frank, you want to talk about what we're going to be doing today?
Sure. So today we're making a catch can for my Honda swapped Fiero. Basically, a lot of Honda guys run two -10AN fittings out of the valve cover, and we're going to go into this box. We're going to add a baffle plate and some -10AN bungs so we can connect it. And we are not going to vent to atmosphere because this is probably not going to be a boosted application, at least not immediately. And that way we will be, so we're actually going to have a total of 4 -10ANs, 2 to the valve cover, 1 to the intake for suction or vacuum, and then the last one is going to be a drain on the bottom so that all the nasty can come out. The whole reason for a catch can is to get the blow-by that comes out of the engine, the crankcase, and especially the water vapor. Normally, you would have some issues with a catch can in the winter because that water vapor will freeze. But in my case, the Fiero is absolutely never, ever, ever, ever going to run anywhere near when the temperature is below 60 degrees, so I'm not too terribly worried about it. So Drew is working on the model that I started with, which was kind of crap. We're going to be making this out of 080 aluminum. I made it in 2 pieces because I have a laser cutter at work, and it's really easy to make flat plates and cut them out really quickly. And then I also have a finger brake, which I'm going to use to put those 2 bends you see on the top. And then right now he's adjusting the color on the bottom piece.
I just didn't like yellow.
Yeah,
yellow
translucent is no bueno.
All right.
Aluminum.
So, you said you wanted to get some tabs in there. Is that so you're gonna just seal weld it with a TIG?
Mm-hmm.
Give a little strength. All right. So since we're in an assembly in Inventor, we can do some extra funky stuff here. So, for example, if I take, let's say this piece, for example. And then go up here. I want to start another sketch. Oh, where is the... Oh, right there. I'm just blind. So we'll start a sketch up here. And you said your wall was 0.080?
That is correct.
Thick? All right. Don't know what gauge that is off the top of my head, but we can do that. So what we can do is I'll just do some construction lines, and since I can see the wall thickness there, I'll just put those lines up there so I know where the wall is, and then we can just start drawing here. So I can do a rectangle, say just about like that. Maybe another one back down here. Whoop, I missed my snap. All right, great. So those ones we're going to make real lines instead of construction lines, and we'll do the same thing. We'll just actually mirror those bad boys. I need to draw a mirror line in first because Inventor is silly like that, where you can't just like draw a line in Inventor like you could before. So, all right. So now I can select these, mirror them over, select my mirror line, apply, bam. All right, so finish sketch. So now I can select those 4 areas and then do an extrusion the other way. And I only need to go 0.08 because that's what the wall thickness is there, and that looks quite nice. Okay, so now I got that in there. Now I can go to the other part. Well, it looks like I went double. I almost hit the bottom of the chamfer instead, so I can go back and fix that real quick. I think I was in the top. I was. So in here, I could change that dimension from 0.16. Oh, okay. Yeah, I'm snapped to it anyway. I'll fix that a different way because I'm lazy.
That's the spirit. That's how we do things around here.
Yep. So I can just go into here, create another sketch, grab that surface, project that geometry. Whoa. Okay, interesting. I'll try to project this geometry down here. Wow, interesting. Anyway, see if it'll let me extrude that now. There we go, that's what I wanted. Yeah, we'll accept that. I don't think it's going to bother anything. Then we can go back here, do the same thing on this side. We can project that geometry in. Good to go. So I'll finish that sketch, extrude that out. Boom, boom. Okay. So now we can go to the bottom piece here and double click on that to get into that part. And now we can start a 2D sketch and then also start, we need to select the surface for our sketch here, and we're going to project our geometry of the slot we just made. Ooh, I was on the wrong surface, but that's no big deal because I can go to folded model. And then I can redefine sketch and then redefine it to this surface. And now I can try to extrude. I only need to go 0.08 and OK and return. So there we go. We've got some slots now. All right, so now we gotta throw in a baffle plate. And Frank, you said you want this right in the middle?
Yeah, I think so.
All right, so I'm gonna create a plane here off of this guy and come in -3 inches because our whatever catch can thing here is 6 inches long. So then I can do create a part, and we're gonna call this the baffle plate. And is this where your assembly
No.
saved?
No. But it's in that directory. So if you just go up, it's in that OneDrive folder, just not in that subfolder. Yeah, there you go. Now, if you navigate, you should be able to find my catch can right there. Fourth one down.
Okay, excellent. And save that. Okay. So now it's going to ask us where we want to start our sketching here. So now I can pick a sketch spot and bing, bang, boom, we're in. All right, so again, I'm going to project some geometries here. And know that I need that as my inside down there, and it looks like that's my inside there, and I need that as well. So now I can basically just draw a rectangle now. Get to snap up here, and then snap down here at this corner, and then we'll just what'd you use for a fillet here?
0.08.
Okay, so we'll a little fillet here, fillet. Oh, it's gonna be nice.
Yeah, that's the stuff.
That is the stuff dreams are made of. All right, so now we have got our dealio here. Now we can turn it off from construction and make these real lines again. Did I go up here by mistake? I did. That's fine. I can just delete that line.
So what's the benefit of starting with a construction line and then changing it to a real line?
It's not. I just forgot.
It's just how you do things?
It was good until I... So, like, this guy
isn't in the right spot.
Is not in the right spot. So I'll have to project. I like when I project geometry to make them construction lines. But the thing is, I just forgot to turn off construction lines when I made the rectangle. So now when I do it, it'll be okay. And now I'll just redo the fillets here. Boom. So yeah, that's how I should have done it the first time, but I'm not very good at this apparently. So
that's okay. You're a professional. You're better at it than I am.
So cool. We got that in there. So now we can extrude, and we'll do it equally both ways. And we'll go 0.08. And cool. So we got that in there now, and now we can put some holes in it. So do you just want the holes scattered throughout?
Yeah, if you could do just an equal distant pattern.
Okay. You want 1/2-inch holes?
Yeah, 1/2-inch holes. And then that way it's really easy for me to pattern things in my laser software.
We can just export a DXF from here.
Yes, but the problem is the way my software works when I import that DXF is that it would make a new part for every single hole. So it'd be whole 1/2-inch hole. 1, 2, 3, 17, 72 million. So when I made my my valve cover plate.
All right, that's 1/2-inch. It looks a little bit big.
That does look a little big. I think we want to go smaller. Maybe try 3/8. Yeah, quarters. Actually, quarter looks good. Because basically what this is going to do is this is going to allow my airflow to go through, and we're going to put some stainless steel mesh or gauze or steel wool or something there to basically let airflow through, but to trap the oil vapors and water vapors. So now Drew's making an array.
Yep, just gotta throw some construction line in here for each direction. So there's 1. And there's 2. So rectangular array, direction 1, and then direction 2. And we'll flippy flop that. And we'll say we want, well, we'll see what 10 looks like at 8.375-inch spacing. And I forgot to select my geometry. That would help. Okay. And here we'll say we'll want 6.
Oh, look at you go.
At 8.375 spacing. So we can actually do 7. And okay. So now we got that. Now we can extrude. And you actually could have extruded 1 hole and then pattern the hole so you wouldn't have to click all these. But I wasn't thinking ahead, so here we are. And we'll...
Only got like 57 of them more to go.
Yeah. Yeah, definitely don't do this. Extrude or pattern features instead. But we're already here, so we're gonna run with it. Oh yeah.
That's the stuff.
All right, so now we're gonna go boop like that and done. So now we got this world's smallest game of Connect 4. Cool. So now we can return this, look at our handiwork, and look at it in there all nice like.
So the only thing I want to add there is another one of those tab and slots.
Oh, yes.
To keep that located. We probably only need one on the top.
Do you want to do one on each side?
Well, it's just more welding.
Okay, we can do one on the top.
I think I just need... I mean, maybe we'll do one on the top and one on the bottom.
Okay. So we'll go to the top plate and do a similar thing to what we did before. So when you're in assembly, if you double click on the part, you actually kind of like open that individual part. So now you can go into like 3D model, start 2D sketch, and now you're modifying this part, even though you're in an assembly. Probably should explain that on the first one, but anyway, so now we can go to project geometry again, and we should pick up our baffle plate like that. Cool. So we'll just do a rectangle. Remember to turn off construction lines this time. And we'll go just like that. Now we'll extrude that down, make a hole. And now we can return back to our baffle plate. And then start sketch up here. Project the geometry of the hole we just made in the top plate. And then extrude that up. I don't know why it's giving me that error, but it really doesn't like it. We'll turn the visibility off of that plane because it's kind of annoying. And then we'll go into our color wheel here. And let's turn this visibility off here real quick so I can do something with this guy. We'll go red for our baffle plate. And then I'll turn our bottom plate back on. And now you can see our slot for the red plate. Cool, cool. All right, now finally to put our inlet and outlet and drain holes in.
Yes, bungs.
Bungs. Gotta love that. So we're gonna pop them in our top piece. And the top of our top piece. All right, so throw a hole, what, right around here?
Oh, yeah.
Yeah, 20 millimeters, you said?
Si, senor.
All right, the cool thing with Inventor, if I type in 20 and then mm, it knows that I want metric. So then 787, that's about what it should be. All right, so again, another 20 millimeter hole for...
So these two are going to be my inlets, and then on the opposite side, on the right-hand side there, yeah, we'll put an outlet. That's going to be same size. We're going to use that to go to the intake manifold to pull vacuum. And then on this side, once Drew extrudes those and makes those into holes.
Okay.
Nice.
Oh, yeah. So we want to do one down here, right?
Yep. Yeah, just about where your cursor is right there in the bottom corner. We'll
also
use that
20 millimeter?
Yep. We'll use that as a drain hole.
Okay. So what I'll do, just make sure I get this right at the bottom, is I'm going to go up 20 millimeters plus 0.08 inches. Haha, like that. And then I can do the same thing, which, I mean, that's 0.867, so I'll just type in the same number here. But you can do functions in there too to be super cool. Actually, I only need to be 10 millimeters because I'm doing it right from the center, but so actually I can do this. Come down 10 millimeters because that was the radius turn off construction lines. And now we'll go 20 millimeter. Well, didn't quite get the millimeter there.
20 meters.
Oh yeah, 20 meters.
Much different.
That's a little different. Okie dokie. Here we are. All right, perfect. So we're right at 80 thousandths above, which is the thickness of our bottom plate. So now we can do that, and now we have our holes.
Nice.
That was a little tutorial on Inventor and a little preview of what Frank's Catch Can is going to look like. Next episode, we might be melting some metal together.
Hopefully.
So stay tuned. Again, if you guys like what we're doing, thumbs up, consider subscribing, and we'll see you on the next one.